The efficiency logic of mixture of experts. JetBrains Mellum2 runs 12 billion parameters, but only pays for 2.5 billion of them per forward pass. Released in June 2026, this open-weight model uses a 64-expert architecture, where only 8 experts are activated for any given token. Unlike the monolithic dense blocks we see in older architectures, this routing mechanism allows the model to maintain the high capacity of a 12 billion parameter system, while operating with the speed and power draw of a small edge model. It is a deliberate engineering choice to optimize for the high-frequency, low-latency environment of an integrated development environment where every millisecond of completion lag matters. This specific sparse activation pattern is what JetBrains calls a focal model, and it directly targets the overhead issues that make frontier models too slow for real-time coding assistance. Native speculative decoding and speculative heads. The architecture includes a multi-token prediction head that doubles as a built-in draft model for speculative decoding. In standard setups, you would need a second, smaller model to guess tokens and speed up the primary model, but Mellum2 integrates this directly into the training objective. By predicting multiple future tokens simultaneously during pre-training, the model effectively learns its own shortcuts. This is paired with grouped query attention and a selective sliding window that only applies to 3 out of every 4 layers, further reducing the KV cache footprint. These technical optimizations mean that in real-world benchmarks, Mellum2 hits over 30 tokens per second on consumer-grade hardware like an RTX 4060. However, the data shows a clear trade-off. This speed is bought by sacrificing the broad, cross-domain reasoning found in larger dense weights. The intelligence gap in reasoning benchmarks. Hard data from the June 2026 technical report reveals that Mellum2 trails smaller dense models like QWin 3.54b on complex reasoning tasks, such as AIME. While it posts a strong 78% on Eval Plus for code generation, its performance on multi-step logical puzzles is noticeably lower than its total parameter count would suggest. This confirms that sparse expert models do not scale intelligence linearly with total weights, rather they scale specialized capacity. For a developer, this means Mellum2 is an excellent router or syntax generator, but it might struggle with high-level architectural refactoring that requires a deep global context. Think of it like a specialist mechanic who is extremely fast at changing tires, but lacks the deep physics knowledge of an automotive engineer. This brings us to how these specialized nodes are being organized into broader autonomous systems. The shift toward model swarms. The release of Mellum2 signals the end of the generalist monolith era for production-grade coding agents. By moving from a single-block LLM to a system of expert nodes, builders are acknowledging that the orchestration layer is now more important than the frontier model itself. The focal model architecture proves that for autonomous coding to be reliable, we need fast, low-cost models to handle high-frequency tasks like routing, RAG summarization, and unit test generation, while reserving expensive frontier reasoning only for the hardest 5% of the problem. This shift allows for the creation of agentic swarms where a thinking variant of a model like Mellum2, trained with reinforcement learning and verifiable rewards, can iterate on its own code before a human ever sees it. Moving forward, the real metric of success won't be a single leaderboard score, but the sub-second latency and error recovery rates of these coordinated multi-model pipelines. Watch for how the unmerged pull requests in common inference libraries settle by late 2026, as native support for these specialized sparse architectures becomes the baseline for local development. Subscribe for more.